Today's warm-up, did we do the Russian nesting doll example together, or did we not get to it? I can't remember. Well, it was on the homework last night, the Russian nesting doll thing, so if we didn't do it together, this is just like that. The length of each side of these equilateral decagons is given. Isn't that kind of fun to call a star an equilateral decagon? So you're never allowed to call it a star again. So, who's putting an equilateral decagon on the top of their Christmas tree? Just kidding. Okay, what's the scale factor from star to star? So what did I train y'all to think of when you hear scale factor? What do you think of? Blank over blank. Every time. Second over first. So you can take the second value and put it over the first. You can do it this way. You don't have to do it this way. Because if you notice, you could have just taken this one and put it over this one, and you would have had 5, 6 right away without touching your calculator, right? So you can take any of the second ones and put them over their first ones. You know what I mean? So as long as you're going backwards when you do that. So the scale factor is 5, 6. That means that this star is getting incrementally smaller by a scale factor of 5, 6. What is the length of the smallest star? So that means to get from star to star, what is the operation that you're doing with 5, 6? Are you adding? Are you multiplying? Are you dividing? Are you subtracting? What is the operation you do? Good, multiplying. No, there's no proofs on the test. We didn't fit proofs into this unit. We didn't incorporate them in this one unit, okay? Not divide, we're going to multiply, Leah, okay? So, to get from here to here, you multiply by 5, 6. Multiply by 5, 6. Multiply by 5, 6. So what we're going to do is take that side and we're going to protect it with parentheses. We're going to multiply by 5, 6. You'll get 25 over 6. Now, if it's a multiple choice problem and the answer choices are decimals, which they might be, you know I don't like rounded answers, but if the answers are rounded answers, then you would pick 4.17, depending on how they rounded it. Okay? Homework answers. It was like a little half sheet of homework, or maybe yours was maybe yours was a full sheet with no back. All right, let's see how far we can get. I was asked to do 9 through 12. Okay. Quadrilateral ABCD and point A prime are graphed on the coordinate grid. Let's see if we can zoom in a little bit. If these two quadrilaterals are similar, use the coordinates of A prime to find the scale factor and the coordinates of C. Sorry, I didn't mean to have a question mark there. Obviously, that was a command, not a question. All right, so what are the coordinates of A and what are the coordinates of A prime? The coordinates of A are -4, 2. And the coordinates of A prime are -2, 1. Okay? We know that scale factor is second over first. The prime, I might not have ever said prime. That's what that little symbol is by the A. It means, it's like Transformers, like Optimus Prime. Anyways, second over first, the prime one is the second one. Okay? So if I put, it doesn't matter which ones I use. If I put second over first, or I could have just put the y value, second over first. So there's our scale factor. What that's saying is that ABCD just shrunk by half, by a scale factor of half. Okay, so you just take everything about ABCD and you just divide it by 2. It's just shrinking, it's getting smaller. What are the coordinates of C prime? Well, all you have to do is find the coordinates of C and multiply it by 1/2, aka divide by 2. So the coordinates of C are 4, 6. So if you multiply that by a scale factor of 1/2, C prime would be 2, 3. Alrighty, moving on. Number 10. At what coordinates should vertex Z be placed to create a quadrilateral that is similar to the original? Okay, now on this one we do need to be careful. We need to find our scale factor. And what we did in the one in the lesson the other day, maybe it was yesterday, was we used side lengths and we put second over first. But if you take a look at these, none of these side lengths are easily countable. So we're going to assume that the center of dilation is 0. You don't need to know that phrase, but anyways, we're going to assume that, and we're just going to use the coordinates instead. Let's find the coordinates of x and the coordinates of q, because those are corresponding points, angles. The coordinates of x are 8, 8. The coordinates of q are 2, 2. Second over first gives us a scale factor of 4. What did they do to that quadrilateral? They multiplied it by 4. They made it 4 times larger. So all I have to do is find the coordinates of s and multiply them by 4. So we're finding a scale factor, then we're using that scale factor. All right. 6, 4 looks like the coordinates of s. So we multiply those accordingly by 4, and we will have the coordinates of z. It will be off the graph. So you couldn't just count rise over run necessarily, because you couldn't use slope because it landed off the graph. Instead, we used our handy-dandy scale factor. Number 11. Guess what we're going to do first? We're going to find the scale factor. Surprise, surprise. Number 11, you can pick any 2 points that you want to work with. You can pick A and F, or I would recommend E and D, either one. Notice that E is at 1, 0, and this one's at 1, 2, 3, 0. So we've got 1, 0, and 3, 0. The scale factor is 3. Second over first, 3 over 1. Scale factor is 3. That means that this star has been enlarged by a scale factor of 3. It's 3 times bigger, the result is. So to find those coordinates, I'm not going to go through this all. I don't want to bore you, but you just find his coordinates, B, multiply them by 3. Find C's coordinates, multiply them by 3. Find D's coordinates, multiply them by 3. I'm hoping I'm really driving this point home since we're doing so many coordinate plane ones. All right, last one. The graph shows PQR and its coordinates. It shows SU. At what coordinate should T be placed to create a similar triangle? So we're going to begin by getting our scale factor. Yep. All we have to do is kind of take what they gave us. Find 2 points that correspond. There we go. S and P. And we can put second over first. Or we can do the x value. Second over first. So there's our scale factor. So all we need to find is where T goes. T corresponds with which point? Which point does T go with in the other triangle? Q, yes. All right, so we take Q, which is 8, 6, and we multiply it by our scale factor. 2015, right? Oh, it's our year. You can't see that writing. I won't use this color anymore. You can't see that very well. The answer is this year. Okay, on the similarity review, complete each of the following statements. Triangle ABC is similar to triangle DEF. Now, you do want to pay attention to what it's asking for. It's asking for the measure of angle E. It's not asking which angle E is congruent to. So you really have to be careful about what the question is asking. It's asking for what it equals, not what it's congruent to. All right? So angle E is listed second, and angle B is listed second. So we know because they're similar polygons, their angles are congruent. So angle E is congruent to angle B. I've talked way too long about such an easy problem. It's 52 degrees. 52, because I checked angle B. Angle F is yet to be determined. We will use good old triangle sum theorem. Subtract those from 180, and the remaining degrees in the triangle is 23 degrees. EF, that means the distance from E to F, the length of segment EF. EF is right here. It is proportional to BC. Remember, when two triangles are similar, their angles are congruent and their sides are proportional. So I could set up a proportion appropriately, and I could say 6 is to 4 as, I could call this X, or I could call it EF, is to 10. So I did circle is to circle as underline is to underline. Or you can find the scale factor, and you can use scale factor when you go to the larger shape, you'd use the improper fraction, and when you go smaller, you'd multiply by the other fraction. You're going to get 15. To find AC, you can set up the same proportion. 6 is to 4 as 12 is to, I'll call it Y. And you will get 8. All right? Get to that, Pavan. All right, so the next portion, I have scale factor 9/2. X is 13.5 or 27 halves. 6, 2, 7 over 5, and 25. Any questions about those? Remember, scale factor second over first, so we did 18 over 4. That's how we got 9/2. Second over first, 14 over 10. And that's how we got 7/5. All right, I'm going to keep going. I was asked if you will have to justify on the test. There will not be a justify box, but by putting that box there, that makes you think, oh, did I really check to see if the sides were proportional, or did I just see a side with an angle in between with another side? You know what I mean? It just helps hold you accountable. No, there will not be a justify box on your test. Oh, I'm dropping markers. Number 6, I got side, angle, side. A, B, C. And the reason is because 8/32 is equivalent to 13.75 over 55. And angle R is congruent to angle A. So that's why it's side, angle, side. Number 7, none or not similar. The reason is 6 over 11 is not equal to 7 over 14. So it would have been side, angle, side had those sides been proportional. Do you have to check? Absolutely, you have to check. Not all right triangles are similar, right? That was on your homework. Not all right triangles are similar. Okay. Next one, this one's of course angle, angle. SPT. And the justification is that it's this angle right here. That's the reflexive property of equality, and then the other angle is already marked. I'm not going to write the long angle names in the box, but that's where the angle, angle comes from. You can add an arc to P. This one you've seen multiple times. You've seen this picture. Side, angle, side, not similar or none. And this one, the sides are proportional. How do you know on number 11 which sides to match up? How do you know? Small over small, medium over medium, large over large. Yeah, that's how, we don't have any angles to go by. So you just pick the smallest one, it goes with the smallest, the medium goes with the medium, and then the leftover ones. Okay? And you set up a proportion. Yep. All right, on the back. All right, 19.2, we're going with it. Cool. Find the missing side, then calculate the perimeter. All right, on the next one, you can do the same thing. You can do inches is 2 miles as inches is 2 miles, and cross multiply. Remember, when you are setting up a proportion, when you're cross multiplying, you never have to convert the units. You never have to convert them units because the inches will cancel and your answer will be left beautifully in miles. All right? 3/4 times 2 divided by 1/2. 3 miles. 14. On a blueprint, 1 inch represents 8 feet. 1 inch represents 8 feet. If the height of the wall is 1.5 inches, what is the height of the real wall in the real building? So we cross multiply that and we get 12. I'm not worried about you doing that. I'm worried about you getting the correct scale factor. So just a reminder, when you're getting scale factor, especially in a problem that has units involved, when you're doing a scale factor, you put second over first, and then you make the units match. There is no such thing as reducing when the units are different. The units have to match to reduce your fraction. And I know you're not really reducing this one because it's over the number 1, but you get what I mean. 8 times 12, 96 over 1. The inches cancel. We wanted the inches to cancel because scale factors don't have units. Okay? Let's work number 15 because I have a sneaking suspicion that you'll see this one again. A 6-foot-tall Lewis. All right, let's draw a Lewis. 6 foot tall. Oh, I'm using the color I don't like to use anymore. Okay. 6-foot-tall Lewis is standing 12 feet away from the base of a tree. He's shorter than the tree, so I need to be careful. I need to draw a tree. It needs to be taller than Lewis. Here's my ground. He's standing 12 feet away from the tree. He casts a 3.5 foot shadow. This is going to be my sun. Oh, that's a bad sun. Looks like flour. We did this one in our notes, I remember. So his shadow is 3.5, like this. If their shadows end at the same point, how tall is the tree? So we really have a triangle inside a triangle. They're similar because of angle, just trust me. And we need to find the height of the tree. So we're going to set up a proportion. This is why I don't teach art. No, just kidding. All right, so if I could say 6 is to x as 3.5 is to, here's the zinger, don't say 12. Good, you add them together. 15.5, very important that you get that denominator correct. So what was hard about this problem? Drawing the picture was hard, and making sure you set up the proportion correctly was hard. The cross multiplying is not hard. The remembering to put your answer with units is not hard. So yeah, if we round it, we're going to get 26.57, so we'll round it to 26.6. Okay? It totally depends on what the problem tells you to round to on the test. Number 16, I'm getting 6.75. So they're 6 feet tall. I like to do height over height equals shadow over shadow. So this person's height is 6 feet. The other person's height is 4.5. Do you get where that came from? 4 feet, 6 inches. Well, 6 is half of 12. So it's 4.5. Okay, Aaliyah, I get you. And this would be x. And it's all feet. It's all feet. So you cross multiply, you get 6.75, or like you were saying, 6 feet 9 inches. That's a good point. On 17, I got 6,347.8 yards, or 3.6 miles. It didn't really say what to put our answer in, yards or miles. Now, when you cross multiply, your answer ends up in yards, so I promise you won't have to do that conversion on the test. You won't need to convert. They're both right answers, though. So So if I call this x, we could say 2,000 is to x, as 2.3 is to 7.3. That 7.3 is the important part. You have to add 5 to 2.3. Okay? On the first one, good. X is 13. On the next one, x is 8. And y is 10/3, I believe. Yes? And on number 20, x is 14/3. And y, 13 is to y as 7 is to 9. You might have ugly fractions on your test, just warning. 13 times 9 divided by 7, ugly answer. Math, enter, enter. 117/7. Okay, guys, 21. Big deal right here. 21, like I just said, is a big deal. We drew the picture for you. You're welcome. We drew the picture. But the problem is, I don't see any triangles. I see 0 triangles in this picture. So we have to be really careful. Let's label what we know. We know a person whose eyes are 5 feet from the ground. So we know this guy who honestly looks like he's picking his nose. It's kind of weird. Anyways, maybe he's just doing this. Anyways, this guy is 5 feet tall, or his eyes are 5 feet off the ground, and he's looking up. He's looking up to the top of a pole, and his line of sight also goes to the top of the building. He knows, somehow he knows that the pole is 25 feet tall. His feet are 30 feet from the base of the pole, and the pole is 90 feet from the base of the building. These are all feet. What is the height of the building? We cannot set up a proportion. You can't just assume trapezoid sides are proportional. You have to have triangles. We only know how to prove triangles guilty of being similar. We didn't learn how to prove any other shapes. So here's the trick. Is everyone looking at the trick? I'm going to be sneaky. I'm going to turn lemons into lemonade. I'm going to turn something that doesn't have triangles into something that does have triangles. So I'm going to take this. I'm going to go. Yes, you must do the sound effect. Yes, you must. All right. Now I have triangles, except all that information, does it translate or does it not translate? Now, what is this value right here? It was 25, but his height is 5, so subtract 5 from it, so that is now 20. I'm going to call this y. From here to here is going to be y. And then guess what? Those numbers from the bottom, they just transfer directly up. We don't need to worry about those. 30 and 90. Cool. Can you add 5 feet to 30 feet? I'm not sure. I wouldn't add the 5 and the 30. All right, anyways, so now we have our new triangle. So I can say 20 is to y as 30 is to, do you see what I'm doing here? 20 is to y as 30 is to, you better grab that whole side, 120. Don't say 90 because we need the whole side that goes along with side y. Are we okay with this? We will cross multiply 120 times 20 divided by 30, and we get y is 80. We didn't just want to know what y was, we wanted to know what x was. So we could take this value and slide it over here. This was 5. We just found out this is 80. So what's the height of the building? It's an 85-foot tall building. So, not a difficult problem, but a tricky problem. Now you know the trick. All right?